This video is called The Return of Frankenstein, one we worked on before. Problem is, this one came to us damaged. These are two legs of a dial, and God, I don't know where these go. Maybe I can silver solder these back on, I don't know. I gotta figure out how they go first, but anyway, I just want you to know this one is damaged. This piece was bent backwards and it's been soldered, and it's gonna have to be repaired at some point. Now we have to figure out what's wrong. Immediately I see something happened here. We got a wheel that's come completely undone. I have to check this out. As is this pivot out of the hole. I have no idea what's going on with this thing. You can also see there's a pin missing from this pillar. That allowed things to come apart. Also, one missing out of this pillar. So this whole plate could come loose, and that's why the wheels fell out. There's also a pin missing from this pillar. There's only one pin holding the dang thing together. And I can also see that the pivot on that the bushing on that escape wheel is really out of whack. I'm going to have to rebush that thing. Wow, what in the heck is with this one? There's a bushing of some sort in there, but that is really strange. Frankenstein again. There's one of the other legs to the dial. I don't know if this was sent with the dial on or not, but boy, what a mess. Okay, while I have this apart, this abomination of a so-called pivot has got to go. That's just terrible. I'm going to take that out of there. I'm going to put a solid piece of brass in there. To do that, I have to find where the pivot hole has to go after I replace. I'm going to use a preacher, and I put that in the pivot hole. Let's see if I can back off. Put this in the pivot hole, and then I put it over here. I hit both of these screws with a hammer, and that put two tiny divots here. Here and here. So once I replace that abomination with a solid piece of brass, I can set these two pins back in those holes, hit that solid piece of brass here, and that'll give me the center of that where the pivot hole has to be drilled. So that's for reference. Okay, got a piece of scrap brass, got it covered with Dykem. I'm going to square that hole off, and then I'm going to solder a piece of that in. We'll mark it and make a permanent place so that this can be rebushed in the future. There's what we put in. Is right here instead of the thin thing. Now I'm going to use the preacher to punch that hole back. Now we've got a solid pivot hole back there for the escape wheel. Instead of that little thin piece of metal, we got a piece of brass in there. It's the same thickness as the rest of the frame. Don't like this. There's still an awful lot of end shake in there. We're going to have to do something with that. We'll take care of it. Apparently, according to the person that sent this to me, the big complaint is that because I don't have the case, I don't have the weights, that when weight is put on this and it's running, that something binds up. And I can see in here, if we look, these plates have been abused and bent and pounded around, and there's a lot of end shake in all of these, particularly this one up here. A lot of end shake. All right, so if I push this all the way over that way, and this one all the way over that way, and then turn it, it's possible for this particular wheel to rub on the shoulder of the that lantern pinion. Further down here, if this is all the way over this way and this is this way, you definitely have a clash of this wheel, the main wheel, with the shoulder of the, and I can see where that might bind, especially when you put weight on this and it pulls it down even further. Likewise, shifting them the other way, this way and this way. Well, no, I guess not that way. But definitely there's something really wrong here, and I don't know. We've got to eliminate the excessive side shake and put them into a position where these are going to make a lot more sense. And I don't want to go about trying to beat the plates any more than they've already been beaten around, although this little piece right here is bent out a little bit. I could eliminate some of that end shake but by bending that in. But if I do, I'm literally forcing this into the binding position. I need to have less end shake this way. I'm going to evaluate this, and I think about the only way we can come about correcting this with any sensibility is to put bushings in that, unlike you're supposed to do, extend beyond the inside of the plate on one or the other sides to reduce the end shake in the direction opposite of what's causing the binding, to reduce the chances of binding. I think this all has to go back to where this came from and how this was put together, making it the Frankenstein's monster that it is. Because, no, here we go, let me try again. This one is 1.2, this is 1.2, and this one is 0.75. Now, why on earth would they suddenly use thinner material to make this wheel? I don't believe it was. I believe this wheel came from someplace else. And therefore, the other reason I say that, this cannot be an original wheel here. The reason I say that is if we look here, and I'll try to bring this up, they literally had to file away a big chunk in this post for this wheel to clear. This wheel clearly came from someplace else. And that means that the positioning of the wheels on the arbors are simply not where they should be. We're just going to have to play the butcher, I guess, and go back and put crazy kinds of bushings in it to give us the end play that we need and the clearances we need for these wheels to stay apart. And I hate to do that, but if they want it to work, that's the only thing we got left to do. In addition, that wheel that I don't think belonged here, look at the pivot here. This is a big bushing that's been soldered in place, and then I don't know what they did, put another bushing inside of it, and what it looks like maybe another bushing inside of it. So that doesn't fit. Let me get this into focus. That pivot seems fine. We go to the other end of the escape wheel. Look here. There's a step down right there. See if I can get a point. If you look at this, here's the arbor, and there's a step down. And I think this is the original pivot surface. And then there's another step down, and that goes now through the pivot hole there. I think this escape wheel is from another movement, because I think this was the original pivot, and this so-called pivot is actually an extension for a seconds hand in another movement. So somebody really cobbled this up by taking a bunch of junk from other movements and putting them together some time ago. But I think this wheel and the escape wheel once went together, because they do mesh very well right in the middle of the, I don't know. Anyway, that's what's creating a problem here. This is just a garbage mess of pieces from movements all over the place, and we're going to do the best we can to make it work. Okay, here's some more evidence that this is really a monster cobbled, and truly a Frankenstein's monster. Remember in the story of Frankenstein's monster, his monster was made up of the parts of a number of people and put together into this monster. Well, this is the so-called second wheel of this movement. But guess what? If we look at this so-called second wheel, what's that little hole right there? What's this even tinier hole than this tinier hole? Well, I'll tell you what they are. This is where, and you can see this circle here. That is where, and see, this has been repeened. Look at all of the peen marks on this. Look at that. Look at that. You know why that was repeened? Because there was a cogged wheel on here, a ratchet. That was a ratchet that was taken off of here, and this is the hole for a click, and these are the two holes for a click spring. So this so-called second wheel of this movement is actually a main wheel from a different movement. So truly, parts from completely taking a main wheel from another movement and turning it into the second wheel of this movement truly makes this a Frankenstein's monster. Okay, I took apart the great wheel, first wheel. I found that the wheel was wobbling a little bit on the arbor too, so I pulled the pin out, bent the legs of the spring, disc spring here down a little bit, put it back on, forced the pin in. Now it's good and tight, and it's not going to wobble. That'll help prevent some of that connection. And while I had it apart, I polished the pivots on these. This one was in pretty bad shape. I actually had to use a file on it to take the deep gouges out of it. And we'll now get this ready to have bushing put in it. Here's the biggest place we've got to do some changes. This shifts forward and this goes back. You can clearly see what's happening here. Let me see if I zoom in on it. Alright, there you go. You've got the main wheel. It's going to rub against, especially if you put weight on that great wheel, it's going to tend to pull it into the shoulder of the lantern pinion. So we've got to make sure that this stays that way, because if this goes even further to the left, and this goes this way with weight, there you go. Yeah, there's your snagging point right there. It's catching on that. So we got to make sure that this wheel stays this way, and the great wheel stays that way. Okay, I'm going to have a bushing put in here that keeps that wheel back so that it can't slide forward and get against. See, if it slides forward that much, it's going to get against, it's going to be catching on that lantern pinion of the upper gear. So, okay, looking at that great wheel, there's how much play we have. We're going to have to make a bushing that's the thickness of this plate, plus let it extend beyond the plate in the back. And we'll have to fit it, maybe cut it a little bit later. But it looks like we're going to need let's see what we got here. It looks like to keep that back enough. 1, 2, 1. Looks like about a little less than 2 millimeters. Probably about 1.5 millimeters beyond. That sounds good to me. That's all the way back. Play here, but there's a little extension down there. It looks like about, we should play, maybe we should add 2 millimeters. Dry fit it, and then see if we need to cut it back a little more. We'll go with, well, I need some end shake. Millimeter wouldn't be enough. Looks like 1.5 between. There's 1. Would a millimeter be enough? Make it pretty close. 1.5 millimeters. I drove out the old bushing. There it is. So we'll measure this up, and we'll make it, make it stick out beyond the front a little bit, so we can, like we would on any other normal one, and we'll get the diameter, thickness, bore from the pivot itself, because this was just a little loose, so we'll make a new one on the lathe. We have an OD of 5.9. Yeah, the bore is going to be 4.25. Right, so if we have a plate, the plate's 1.75 millimeters. We said we wanted to go inside of that, 1.5 to off push that thing back. I want to leave about 1.25 on the outside as a collar around the whole thing. And then it's 1.75 is the thickness of the plates, so these three together is 450. So we're going to go with a length, total length of 4.5 millimeters. What did we say the OD was? 5.9. So 5.9 outside diameter of going through the hole, and that's OD through the plate, and we want a bore of 4.25. I'll go cut that out. Okay, we'll face this off. Good enough. Okay. So, right there. Center drill. Back this off. I'm going to put a toothpick in there so I don't lose it. Okay, here's our piece. Got a little marking on it, and it's going to go on this way, and just snug, so I'm going to have to broach it just a tiny bit, and then it will go in here like so. And we'll pin that in there. So I have a collar out here, and this will go in here like this, and it will be spaced out 1 1/4, but I got to broach that just a tiny bit to get this to fit. Alright, with that new arbor in there, I've got to still tighten it down. There's almost no end shake, but even if I move this wheel either way, alright, I'm not going to get that binding up against the edge anymore. That's going to do it, and all I got to do is just take a little bit of that. I start out with 1.5 millimeters on the inside. I'm just going to attach that and work with it, file it down until I get just a little bit of end shake, and then that will be that will resolve at least that problem. They used to rub in there. That's going to be much better. Okay, we got a free spinning wheel now, and it has a tiny bit of end shake. I don't want too much end shake because I don't want that thing moving enough to bind again. But this is going to turn freely. It's got a nice new bushing up front, so that won't flop around any. It should hold good and steady. The other thing is this bushing has it's much deeper. The other one was just the thickness of the plate. This one is 3 times as thick as the plate. So it shouldn't wear out for a very, very long time. But I found another spot for interference here. Here's the wheel. This is the wheel here. that has the lifts on it for the strike. And this is the next to last wheel. Watch the pins. They do, don't they? Let's see. Yep, there we go. We got pins that are hitting the shroud. Actually hit the shroud on the lantern pinion, because this thing is all out of whack. I think what I'll do is I'll put that upper one. Need to check and see which pins are actually hitting. Two things I can do. I can take a little bit off of that shroud by putting it into the lathe using a file and turn that down just a tad, and then making sure that the pins are left here. These that are slightly bent, okay, bend them back. This is the fly, the governor, on the strike side. Look at the thickness of the arbor there. When we get to the lantern pinion, and then what in the heck did they do to that arbor? And look at the shoulder on that on that lantern pinion. Cute, huh? Well, we've got the strike side so that it functions properly. And I turned down the shroud on that lantern pinion so that the pins on that lift the hammer don't hit that shroud. So I'm tired. My desk is a mess and I'm going upstairs for a while. Okay. Tried to drill that out, put a new bushing in. The bushing within a bushing within a bushing completely came apart. So I'm going to have to, I can either cut that all out of there and put in a solid piece, or I think probably easier will be to take a piece of plain round, cut it to that size on the lathe, put it in, and then drill a new hole. I didn't show it, but I used distances from other pivot holes in different directions to find the center. And then I drilled out the hole. Now I gotta broach it to make it fit. I tried cutting a round piece, putting it in there, and the same thing happened. It just broke out again. So what I'm going to do is I'm going to cut this out and I'll drill a new hole. But first I've got to determine original centers. Now, let me clean this up. Be right back. Alright, finding a center of a hole like this, if you've lost it, under some circumstances would be relatively easy. You could take the opposing plates and you could put them together and find out where the holes lined up like this. But we can't do that in this case because there's too much junk all over. I can't even get a flat surface to get those together. The other way would be if you had a depthing tool Well, I've never owned a depthing tool. They're expensive. I know they can be made, but I've never taken the time to make one. So, what can we do to, when I do this, take that all out of there and put a new piece in there? How can I find the center? Well, here's what I've decided to do. Here's the one I need a pivot for. I have a very thin piece of brass, and I measured the hole, and I drilled a hole in this piece of brass. That's the same size as that pivot. And now what I'm going to do is I'm going to put these back in here, and I'm going to put this piece of brass over that hole to make a pivot hole. And what I can do to hold it in place, this is just for measurement purposes, is I'm going to use a clamp to hold that in place. Now I'm going to put the wheels in. I'll be right back. Okay, have the wheels in. That third wheel, as you can see, it's not in there parallel to the other parts. It's big crooked. This wheel turns, it doesn't even mesh. Alright, so what we got to do is we got to move that metal piece that we put in there with the pivot in it until it does mesh. And we got to find a spot where it will mesh, and we can then clamp it in place, and we will see. Oh, I got that. Catch it. It's too tight. Anyway, I'm going to manipulate that thing until I can get these wheels to turn real like they should. And when I get that, what I will do is I will examine the depth of the teeth from one wheel into the lantern pinion of another wheel until this meshes with this, and this meshes with the escape wheel perfectly, and then clamp that piece in place, and that'll give us the proper position of that hole. And then I can do some measuring, and I can do some marking, and I can get things to where they will work. And let me do that. And now I've got that pivot in that enormous hole with the metal little piece of brass behind it with the pivot hole in it, where these all mesh. And what I'm going to do is I'm going to look inside, and I'm going to look individually in here to see what the depth is of these teeth here with the lantern pinion here. I'm going to very carefully check that, move these till that's proper depth, move this one until that's proper depth, and everything is perfect. Then that will be in position, clamped in position. Then I can do some measurements from this pivot hole, or this pivot, to this pivot, and I'll be able to make a mark as to what the distance is, what that distance should be, or I can measure it with my calipers, what that distance should be. I can also reference this pivot hole, with this pivot hole over here with my caliper, give me a second mark, and then I can put some layout die on here, make marks. I'll find my center, cut the piece out, and replace that pivot hole, and we should have a movement that will work much better than it did before. I've got that adjusted now, where the depth of mesh in here is as close as I can get it to being proper, and the depth of mesh in here is as close as I can get it. So this will turn in this position, and that's how easy it turns. Alright, so that then, right there, is the correct position of that pivot, or where that pivot should be. So I'm going to cut that out of there, and what I'm going to do is I'm going to mark that first, and I'm going to do some measuring, and we'll make some marks on here as to exactly where that that pivot has to be. I'll get some Dykeman put on here. Okay, I measured this distance, and I measured this distance over to this hole, and I measured this distance, and besides those three, then I measured from exactly the left edge of the frame here, and I measured from the top down to the pivot, and made a little diagram, put the measurements in there, wrote down the measurements, and now I can safely take that apart, put a new piece of brass in, and we'll make it so that it's a new solid piece, and pieces aren't going to be coming out with a bushing inside a bushing inside a bushing. Okay, pins out, flip this over, take this off. Come on. Okay, when we take these back out, and you can see what I did. A piece of metal with a hole in it. Well, that's a nice clear shot. I'm going to do a remeasuring inside here again. Okay, rechecked measurements, looks pretty good. Can take that off. Again, there's what I use, is just a thin piece of brass. Put a hole in it that fits. Move that around until everything meshed properly, and now we know we get the measurements for putting the center hole back. Okay, we have a piece of brass out there now that we can put a hole in. Alright. I marked it from the measurements. I drilled a hole, and I put a bushing in it so that it can be replaced in the future. And there we are. Everything works fine now. Now I can clean this thing up, start to put it back together. Alright, before I can put the movement back together, I've got to get this dial fixed so that it'll go on, because I'm going to have to use the front plate of the clock as a template. I'm going to have to make some parts, I guess, because these are all broken off. Only have two of these, which are, and I think this one is probably to hold this plate onto the chapter ring onto the front. So what I did first, before I do anything, is I just absolutely thoroughly cleaned these. These were so covered with filth. I can't get everything off, but I really cleaned them. And you see there are 4 pieces here This can't go on here. I have no idea what's going on there. And I have to make a piece for this. And then I'm going, God, I don't know. And I'm going to have to make at least one or two of these that'll hold the whole thing onto the front plate. Anyway, after cleaning these, I did find there is a very slight color difference here. And cleaning it, it's obvious that that chapter ring was silvered. And what I'm going to do is I'm going to re-silver that before I put this all back together too. Make it a little more presentable. First thing I think I gotta do is I gotta fix this little arch on the top has been rather crudely, I mean really crudely soldered onto this, and it's extremely loose. I mean, it's gonna come off anyway. So I'm going to clean this up, and I think probably what I'll do is I'll make a strap to go across here and solder a brass strap that will hold that much more rigidly. But first I got to see how this fits on there to what I can do and what I can't do. Put the center wheel and the two main wheels in because those are the ones that are most important for determining how this goes on, and we will work with this and see what we got to do to fit it up. What they did to this, the size of this hole. Compared to the size of this hole. They actually cut this out. Notice it extends beyond the scribed. This comes right to the scribe line. But when they did that, they also had to cheat on the chapter ring. It took a chunk out of the chapter ring for that to fit on there like that, because they had to enlarge that hole. Why? Well, take the chapter ring back off, put it on the plate here. Because this dial gonna center you can't really center everything. That's centered. Do the best you can there. And that goes into it. You gotta move it this way. So that has to be moved over that way. And that's why they had to cheat on the hole. Okay, we're gonna try best fitting this, and then we can determine where the posts have to go, the attaching posts, the feet. Okay, I've lined those holes up about as best I can. Clamp them together. Now let's take a look at the back. See where we're at with that. Okay, flip it over. Put some props under here. Okay. And that's what that little extension was. One of the posts has to go there. One of the posts has to go here. Let's see, where are the others? One of them they have is up here. I guess there's only 3. They only have 3 posts that hold this. Okay. The other one's up here, and it goes through that arch. So before I can mark these, this arch has got to be firmly attached. And so that's the first thing I'm going to do now is go back, clean this up, make a strip across there, silver solder it, and make this rigid so that there's a good rigid attachment. Okay, we got the arch cleaned. Only took me about 20 minutes. But I got all the old solder off, cleaned it down to plain brass. That'll make it better to solder. And now we got to clean this garbage off. That's looking better. Okay, we've removed this abomination. Absolutely doesn't need to be there. It was put there because they didn't want to replace the feet on the back of the dial. So we're going to make that right. Now we have that area cleaned up. Looks much better. Now we're going to fit the pieces on the dial that we need to get this on here. All right, here's where the three legs have to go to attach the dial to the plate. One will be this dot right here, which will be on the arch, which still has to be soldered onto the rest of the plate, and it'll be a post that will be then soldered here. Second one will be here, and the third one will be here. And then we get rid of all that junk that was on there before. Okay. I soldered on 2 reinforcing pieces of brass. That'll keep that from bending like it was. Keeps that straight. Looks a little better. Cleaned it up some. Now we're going to make put the pegs on to hold the dial. One of the things that has to be done is, I did a little resilvering on this, just to put this chapter ring on the brass, and then it gets held on with steel pins that go through holes that are very, very close to the dial plate. The problem is that one of them is broken off. Now I could make a new one and solder it on, but I really don't want to heat up the chapter ring and possibly do damage, if that's where they go, do damage to the thing. So I'm going to file this down and then make a new piece with a hole in the bottom, file it flush, make a hole just at the same depth as these are, And then I think I'll use JB metal weld to glue it on, and we'll see how that works. It shows the chapter ring on the front. These are what extend through the back, and this one is missing. I measured these. These are very crudely done, but they're about 6.5 millimeters. There's a nice piece of brass that's 7 millimeters, won't fit, so I'll cut this down in a lathe. And I think what I will do, there is a little tiny bit of space in between the plate and the chapter ring. So if I were to just glue this directly to that back of that chapter ring with that metal epoxy, I'm not sure how well it would hold up. So what I'm going to take is, I've got some relatively thin brass. I will either solder or screw on the back of this a little square of brass countersink so it sits flush, but will give a broader surface area for me to put down more epoxy, and I think that that will do a better job of holding that in place so it doesn't come off. And we will then drill a hole at the level that needs to be, and we'll have restored the security of the chapter ring to the dial plate. Okay, I've cut this down a little bit. Let's see how close that will be. Okay, that's pretty good. I need to allow a little bit of play, so I'll cut it down another tiny bit. Alright, here we are. And here's where it's got to go. There's the piece I just turned. Goes in there. And then we will attach that to the chapter ring. Drill a hole through here, the level of the plate, so that it can be held down with a pin, just like the others. Okay, I'm going to solder this to this little tab. It's very thin brass, and then that will go on the chapter ring, and I can cover this whole, put the epoxy on the bottom of this as well as on the top, and that'll give a much more stable hold so it doesn't break off again. Okay, that's now soldered, and when I put this onto the chapter ring with epoxy, then this whole surface will help to provide a much better grip, so it doesn't break off. Make it a little stronger. And that's how it'll fit. And then I'll mark to drill a hole on the side so that it'll hold that tight. Got it in place with the epoxy on it, and what I did was I just put this so that I could see that it was going through the holes, and that's where she'll stay until she dries. Now the stuff I'm using, it's not JB Weld, it's something called Eel-Ho. Got a weird name. Metal Repair Super Adhesive Epoxy. I've used it before, it works very well. And the ingredients are listed. It is an epoxy. And it says, let's see where it is. Epoxy resin, silicon powder, which is like a fine sand, iron powder, carbon black, and additives. So we'll let that harden for 24 hours, and then we can get back to this tomorrow. I'm going to quit for tonight. Okay, left it dry overnight. Then I used my Dremel grinder and carefully chiseled it away. There's our new post. Feels very sturdy, and we'll now see if it works. Okay, so here's where we're going to put it. There's the number 12. Here's our new post. So that's going to go on here like this. And snaps right in. There's the new hole. Nice and close to the surface, just like the others. That will clamp down real nice. Be nice and firm. No missing post anymore. Okay, cleaned this up. Took a lot of dings and scratches and bings and bangs out of it. Filled a hole here. Filled a hole here. Got one more to fill up here. But otherwise, we're looking pretty good now. We need to make 2 new holes for dial posts, and we'll make some new dial posts. But that looks a lot better. Okay, final hole filled. Got that whole plate cleaned up pretty good. Now we'll start by fitting on the dial. Okay. There's a little tiny wire goes on here that acts as the stop pin during the strike sequence. The old one was completely mangled and deteriorated. So I made a new one. This is very strong, fine steel. And I silver soldered it on here rather than trying to. The other one was in a hole in the arbor. This arbor is questionable anyway. But rather than drill another hole and weaken it further, I just put a tiny, tiny piece of silver solder on there, and that's good and solid. All right. We need to put some legs on the dial that will go into holes on the plate, on the front plate of the movement to hold the dial. The ones that were on there were only 3 of them, and they're actually 2 of them were this size, 1 of them was this size. They've been mangled, filed, they've been soldered a number of times. They're just a mess. So what I'm going to do is I'm going to just make new ones, and we will attach them to the back of the dial, just as I did this one here for the back of the chapter ring. So we'll make plugs like this. They'll be this length, and I'm going to turn them out of the brass that I have here, and got some brass rod. So I'll decide which one of these I'm going to use. We'll leave a shoulder and a post with a hole in it, and go from there. Alright, this post that came off of there, boy, you talk about a cobbled up mess. Evidently this was too long, didn't fit right, I don't know where, probably taken from another movement somewhere. Anyway, they actually had to put a piece of brass wire on there, like in place of a washer to take up space. Anyway, we'll measure these up, see what we can come up with. Okay, so I'm going to use this stock. It's 1/4 inch stock. We're going to cut it. It's about 7.1 millimeters wide. So total length is going to be 24 inches, 17 to the shoulder, then 7 long. Cut this end down to 4 millimeters. Cut it off and drill a hole in each one and make 4 of them. Okay, 4 new feet made. Now we have to fit them and attach them to the dial. Okay, there's where the pins will come through. Now I have to drill holes right at the level of the plate, and then I can put those, mark them and put them on the dial. Okay, and now I got to put a hole in each of these so I can put a pin through them, but they got to be just at the, as close to the edge of the plate as they can be. So I have a piece of scrap brass here that's the same thickness as the plate. I drilled the same hole in it. I'm going to put that in a little vise and drill a hole at the level of the plate. Okay, holes drilled. Now I can put some feet on them, get them positioned on the back of the dial. Cut some metal here. These don't have to be very exact. Okay, now we just need 4 of them. Pound them flat. So we'll do 1, 2, 3, and 4. Okay, there we go. Flux here, flux here, set that on there, tiny piece of silver solder, put some flux on it. Oops. Come on. Shaky hands. Shaky hands. Come on. There we go. Okay. Okay. Okay, I've put these back in because I have to know where this goes. Line it up before I know where these go. So what I'm going to do is I'm going to put these in with the pins, in position. Like so. Then I'm going to arrange this on top exactly how it's got to go. And see what problems we have. All right, well, what I've got to do is I've got to remove a little bit of that one piece in there. So when this is all centered, like so, what I'll do is I put some of the adhesive on these things, set this down in place, put a little weight on it, and just let the adhesive dry. When that's done, we're set. Put the mastic on. That's this stuff here that I mixed up. And we're just going to now let that sit for several hours before we finish things up. Okay, there they are. Now I'll get this dial all put together. I've been a little worried about this stuff holding under any pressure. Maybe breaking off. So I thought, well, these are all within the area of this dial that ends up getting covered by the chapter ring. And the chapter ring itself, anyway, go over that and cover anything. So I have some 348 screws, and I thought what I'd do, as I've done here, is put a drill, tap, and put a screw into each one of those. It'll be hidden by the chapter ring, and just doubly reinforce them so they don't ever come off. It still bothers me that this is what was on there that came in the mail, and they were all busted off. Looks like somebody had soldered them on before. One of these at least had some kind of glue on it, and so in redoing those, and I put them on with a high-strength epoxy, I still don't trust it, so let's make it double. I'm going to measure over where I need to drill by using this. See, I need to come in about that far to the center of that post, and I will, let's say like this, so that will go here. And we will make a little mark here. Okay. And we've got to measure over this far on this one to the center. And we will see where that goes. Here. And I'm close. Let's see. Yeah, it looks sideways where that mark is. I move it back this way a little bit. All right, here we go. so that where I'm going to drill is right here. Make a mark for my drill. Make sure I'm still there. So for a 440 or a 348 drill, I need a number or tap. I need a number 47 drill. Mark how deep I have to go. And then I've got a tap here, and I've got it in a Jacob's chuck. Just makes it a lot easier to deal with. I'll put it this way, and we will start tapping. And as soon as I feel it bind, I back off. Don't want to break the tap off. Okay, bring it back out again, clear chips. Time with my hands. Okay. Make sure I have it deep enough. Getting close. I need to go just a tad deeper. Then I'm going to put this in the lathe, cut that screw head down. It doesn't need to be that big. I need to tap that just a tad deeper. I also will take this tool, and then I will chamfer that hole. And now I'll take that screw over and put it in the lathe. Cut that head down a little bit. There's the head now. And I will go put this in the lathe. Okay, there's now the head. After I cut it narrower. We'll see how that goes. Okay, going down, fits nicely, And we'll file that off, but right now what I'm going to do is, before I tighten it down, oh, here we go. Put a tiny tab of thread lock on it, Loctite. And I'll put this in. Okay, very good. I feel a lot better about that leg being secured now. And then let's take and wipe this off. Then I take a file and file that down a little bit. And we'll have those nice and secure. I think I'll do the other two, and I'll feel better about that. So, got two in there. I'll do the other two. Now with the heads ground off, they look like rivets. Well, anyway, I think those legs are nice and secure now, and I'm not going to have to worry about them falling off on the way back. Okay, I got this all back together, and I got it where it functions right, it strikes correctly, everything seems, I could send it back this way. But I'm looking at this center shaft, and I just don't like that slop. I'm going to take it back apart and rebush that center. That's just too loose. And there's the new bushing. And it's better than it was. And it's got a little more beef to it, so it should last a long time. Okay, we're going to turn this with the key. I'm going to put thumbnail pressure on the strike side. Let me turn it this way just a bit. Turn. Left goes into warning. Looks good to me. Okay, let's oil it and put it back together. Okay, this is running with about 700 grams, but there's still a problem with it. Alright, with a lot of weight on it, it will run. They said they had 10 pounds on it, so I decided I'm not going to mess with it anymore. I'd really like to replace that arbor on that escape wheel, but if it's running, doing what it's supposed to do, I'm going to leave the rest alone.